Hey, welcome back. Today we are looking at the concept of transformers. So, in machine learning, every couple of years, somebody invents something new and crazy, which will make us consider all the previous understanding and v- enable us to envision stuff what was previously considered impossible. So, today, what we are looking at is something called transformers. So, why transformers are important and where they are used. So, transformers are models which can translate text, write poems and write articles, and even generate computer code. And as you are already aware, uh, for any given transformers, have been trained on a variety of machine learning models. And the examples of transformers basically are BERT, which is a Google trained language model, GPT-3, one we will be looking at closely in this course, and the another one is T5. And until transformers, um, we used to understand text with the help of a neural network, which was previously called as recurrent neural network, which is represented in the diagram here. So, to translate a sentence from English to French, RNN would take an English sentence as an input and process each word one by one sequentially and convert them into French. So, in language, the order of word matters, uh, and we cannot just stifle them around. Let's take an example in the next one. So the limitation of RNN is, so if you have a very large sentence, it cannot get the information at the start of the sentence, what context it was and what meaning it meant. And the another thing is, since it is done sequentially, you cannot do uh, RNN in parallel. Those are the two limitations of RNN. And let's look at this example which I was talking about. So Jane went looking for trouble and trouble went looking for Jane are completely two different words. So they are not the same. So the model that deals with sentences has to capture the word order. Since RNN does this by looking each of this word sequentially, we have two major issues with RNN. So when you have a very large sequences of text paragraphs or essay, by the time they are processed the end of the paragraph, it actually forgets what the beginning meant. So the context of this paragraph, the context of the sequences is lost. Since RNN is processed sequentially, it loses the so it cannot parallelize well. So these are the two limitations. And now let's come back to transformers. So transformers were initially created by Google with a Canadian university, if I remember right. And the initial purpose why it was designed was to do translations. So unlike RNN, transformers could be parallelized. That is, if you use the right hardware like a GPU, you can train pretty large models in a finite time. Then probably RNNs could have been trained. So if we look at the example of GPT-3, GPT-3 was trained with 45 terabytes of data, and that basically which implies the entire public, almost the entire public web. Yeah, approximately the entire public web. So in layman terms, combine a model that scales well with a massive data set, and the results will blow your mind. So that's basically what transformers are. And so if you look at this example here, these are all the components of a transformer. And the three major ones we need to understand here are positional encoding, attention, and self attention. So these are the three concepts we need to be aware of, or we can also call them the three main innovations which make transformers work very well. So when it comes to positional encoding, so trying to translate a text from English to French, instead of looking at the word sequentially, take each word in a sentence, and before you feed it into neural network, slap it with a number on it depending on what number word is it in the sentence, and save that info of word order in the data itself rather than in the structure of neural network. So if you look at this example, we have clustered the words and assigned numbers to each of the word. And when you train the new network with lots of text data, and it also learns how to interpret those positional encodings in a way, neural network learns the importance of the word order from the data. This is the high level understanding of positional encoding. And after positional encoding here, let's move on to uh, attention. So what is attention? Imagine trying to translate the sentence, English sentence, into French, and one bad way of trying to do it is convert each word by word. So in French, some words are flipped. For example, European comes before economic, and attention mechanism is a neural network structural mechanism which allows text model to look at every single word in the original sentence when making a decision on how to translate the word in the open sentence. It's a sort of heat map that shows where the word is attending, where when it's output each words in the French sentence, so you can assume it as a heat map for attention. So you're not going to do word by word, because some of the meaning and the way each vernacular language is structured is different, so it won't work that way. So instead we have to look at the context of the entire word, and then we have to do the translate. So this is the heat map for attention which we were talking about previously, and it's taken from a paper, and that's basically what I'm demoing it to you here. And here the next one is self attention. So previously, with respect to attention, what we understood was to do with aligning words in English and French. What if the goal is to understand uh, underlying meaning, enabling you to build a network which can do any number of language tasks? So what's incredible about neural network like transformers is, as they analyze tons of data, they begin to interpret this internal representation of language automatically. So example, when they may learn words like programmer, software developer, software engineer are synonymous, they also learn rules of the grammar, gender, and tense. So, the better internal representation of the language the neural network learns, the better it will be in any language task. So, the most effective way to do this is to turn on as attention while reading the input text itself. So let's look at the example here. So by looking at the uh, context of the surrounding words, self-attention helps neural network understand the word in context and word around it. So if you look at this example, server can I have a check is totally different from looks like I just crashed the server. So even though actors in both of them is server, but basically uh, the meaning is completely different. So if you understand the context and if you are trained on it, you can actually make better inferences. So this is basically what the idea of transformers is. And the three major stuff you need to understand is RNNs were basically what if you have worked on neural networks and training them. So that's basically what RNNs are. And you know the limitations of RNN we just discussed. And after RNN, we looked at what are transformers and how they might be useful. Uh, and apart then we looked at the three main innovations of transformers. One is personal encodings, attention, and self attention. So, this basically wraps up the first lecture. In the next one, we are going to look at ChatGPT in detail. Thank you for joining.